Hello, I am an IT student at UAU. My name is Shamma Alawi. I will present with my colleague Sarah Asha and Tarfa our project, which is mining large-scale Twitter data for Covid-19 crisis management. Then we will show a demo of our implementation. We will be going to introduce our project, motivation, novelty and contribution, system architecture, implementation, and experiments. Let us start with the project idea. This project aims to analyze the Twitter text data for pandemic crisis management, visualize the analysis for a better understanding, and a web application has been developed for analysis and visualization. The implemented web application will help to identify and locate crises arising in different geographic locations. As well, it will assist us by giving a detailed analysis and answers many questions like, what is the most pressing issue of a particular area? What is the public sentiment of a locality about a certain initiative, for example lockdown? And we believe it will be useful for different entities, the government or non-government organization to support the citizens. The project implementation has been done using different mining techniques such as natural language processing, sentiment analysis, geolocation mining, and visualization. Our motivation was the initiative to help mitigate the adverse effects of the current global pandemic crisis. We decided to use Twitter's data because it is one of the most widely used social media platforms to express thoughts and emotion, and Twitter data are abundant and freely available. The novelty and contribution of our project. We have studied many relevant works and we found that there is no work similar to our work in terms of different features: text classification, sentiment analysis in general, Twitter sentiment analysis, Covid-19 sentiment analysis, and big data.
Hello everyone, my name is Tarfa Al-Azizi. Our overall system architecture includes major elements. As you can see, we have the data files and the user. First, the data files. It contains the Twitter data, the text, and the metadata, and all of it collected offline. Second, the user can generate a request to the web server based on a specific keyword and a time frame. The web server will search tweets from the data files. Then, for each tweet obtained from the search result, sentiment analysis will be done using the text blob sentiment analysis tool. Finally, it will produce an analysis visualization output for the user. For the implementation part, we use several things to build up our web application. The development requirements that we used are VS Code, Django, Python, JavaScript, HTML, CSS, Plotly for the map visual, Twitter hydrator tool, and text blob for the sentiment analysis. And we choose specifically text blob because it is the most accurate tool for the sentiment analysis. For our data, we use Twitter text with geotag, and the size per day is on average of 4 GB, and the average tweets in each day are 400,000 tweets. In total, for the code lines, we have 1875 lines, and it's divided on Python code, HTML code, JavaScript code, and CSS code. The main communication in our web application is between the browser and the server, which are the front end and the back end. So the front end will send the HTTP request to the back end, and the back end responds with the HTTP response. And as you can see down, we have the code for the front end and the back end.
Hello, my name is Sarah Zanhani. I will be moving on to the pseudocode. First of all, the server will be launched, then the client will browse the URL. After that, the page will load and the client will enter the dates and a keyword. This will generate a post request which will go to the server, and the server will receive the request to process it. The server will enter the while loop, and this while loop will load the JSON file corresponding to the date. Then it will search for the tweets in the JSON file for the specific keyword. Then it will do a geolocation summarization and a sentiment analysis. After that, it will do a visualization summarization, which includes the geolocation and sentiment. Then it will move to the next stage until the loop is finished. So when the loop is finished, it will send the response to the client. For the experiment part, we experimented several aspects of the web application, starting with the number of tweets versus running time of analyzing the tweets in the JSON file. And we used 3 keywords: coronavirus, lockdown, and vaccine. The results showed that when using more tweets, the more running time it takes to analyze the tweets and display the results. For example, the keyword coronavirus is the most tweeted keyword among the others. Therefore, it takes a long running time. In this part, we searched 3 different keywords from one JSON file, coronavirus, lockdown, and vaccine, to define the top 10 most tweeted countries that have used these keywords on the tweets and their sentiment percentage. We see that USA is the top most tweeted country for the keyword coronavirus with 14,981 tweets. And also, USA is the top most tweeted country for the keyword lockdown with 88 tweets. Also, USA is the top in terms of the keyword vaccine with 255 tweets. Also, we did the same to define the top 10 most tweeted cities that have used these keywords on the tweets and their sentiment percentage. We see that London is the most tweeted city in terms of the keyword coronavirus with 1,016 tweets, and Washington is the most tweeted city in terms of lockdown with 9 tweets, although it's few tweets. And finally, in terms of vaccine, Lagos is the top with 19 tweets. We chose the same keyword to define the top 10 most positive cities, and we calculated the positive sentiment percentage for each city. Then based on this value, we chose the top 10 most positive cities. The top most positive city in terms of coronavirus is Halifax in USA with 62.5%. And in terms of lockdown, Atlanta is the top with 100%. In terms of vaccine, Geneva in Switzerland is most positive with 90%. Also, we chose the same keywords, but with calculating the negative sentiment percentage value and sort the list of cities based on this value. So the most negative city in terms of coronavirus is San Jose in USA with 88.6%. And in terms of lockdown, Adelaide in Australia is the top with 100%. Last, in terms of vaccine, Pittsburgh in USA with 50%.
Finally, our web application based on performing sentiment analysis of people's thoughts and emotions in Twitter text, a process with several stages starting from Twitter text collection and extraction until output visualization. And we believe that the proposed work will make a significant impact and help the country. Now we will show the demo.
Hello everyone, my name is Hashim Mansouri. Now I'm going to show you the video of the demo of our web application. So here I am launching the server by typing python manage py run server. Then I use this URL to browse. Now it shows me no search record, date, which is 2nd of February. And the keyword is corona. This process takes around 2 minutes and a half. So this is the web application after the search. Here we have the current search item, the top 10 tweeted cities, which include the city name, the country name, number of tweets and percentages. And here we have the word map, which has colored bubbles, which the color indicates the level of the sentiments and the size of the bubble indicates the number of tweets. And each bubble has a summary status, so the user can hover the mouse over the bubbles to see the summary status, which includes the coordinates, city name, number of tweets, and sentiment level. And on the right we have the top 10 negative tweets, then top 10 positive tweets, and for each tweet we have the city of the user and the country. For this search we have analyzed 532,000 tweets, and we have at the top right the sentiment percentages, which is at the word level, so it means like 44% of the 532,000 tweets is positive, 18 is negative, 38 is neutral. So this is our web application user interface, and this is our project. I hope that you like it. Thank you for watching and listening.